So we saw in the first 2 weeks of the course that a programming language was a formalized language that was useful because you could write text, source code in that language, and then that text could be translated into code that would make sense for the machine, so assembly code. So a programming language was some target for the human to describe the task that they want to do, and then some automatic translation was performed to translate this task to a language that the machine understands. Now comes the next question, which is who is performing this translation, this automatic translation? And the answer is that it's programs again. So some programs are performing this translation, and there are actually two types of programs, compilers and interpreters. And my goal here is to try to describe the difference between the two, describe what they are first, and describe the difference between the two in second. So let's go back to this translation to machine code. So we're starting from some task that was very abstract, if you remember, and that's what the human wants to perform. And we want to have some program that can be run on a machine. So something I called assembly code. This was the language that the machine understood. And the programming language, the goal of a programming language was to sit somewhere in between. So we had here a programming language or source code, which is text in that programming language. And the task of programming was to go here all the way to a programming language, to source code. And then there was an automatic translation going all the way to assembly code. Now, I didn't talk much about this automatic translation, but the point is it could go through several different programming languages. So you could translate from one language to another, let's say PL2, and then another, and so on, many times, up until you hit assembly code. And in general, the last or the second to last language would be machine code. So remember, this had to do with virtual machines. Okay, so the point is each of those translations is automated, so you can automate the whole chain and do all of it at once. So let's be a bit more concrete here. So we could start with Python here, and we could go all the way to the Python virtual machine. Okay, and then depending on which machine you're running this on, use different endpoints, different assembly codes at the end, because there isn't just one either. So this would be assembly code 2, assembly code 3, and this is assembly code 1. So that's one option, and that's one advantage of Python, is that you transit through this Python virtual machine, so it will be the same for every machine you might use. So that's one possibility, but nothing says it has to be the only one. So here is another one. You could go from Python to JavaScript, and maybe this transits through a virtual machine, but once you're in JavaScript, then you're very good because JavaScript is extremely portable. That's what powers the web, and you can translate into many different assembly codes. So that's two different options for Python, and certainly the first one here is more common than the second, but I want to really illustrate that there are different options, and none of them is more valid than another. In particular, this makes it possible for people to run, so the transition through JavaScript makes it possible for people to run Python without installing anything on their computer, because presumably they already have a browser installed, and once they have the browser, well, they probably have JavaScript as well, and so you can run Python program within that browser, and that's the advantage of using JavaScript. So as you go from the task to the assembly code, it's important to remember that the intermediate programming languages lower the level of abstraction. So this Python might be very appropriate for the task you want to do, but the Python virtual machine is very impractical to program in. But that's okay. No human has to touch this, and no human has to actually touch assembly code, because all the translation in between will be done automatically. Okay, so now I want to give two examples of the two examples I just talked about. So the first one will go from Python to machine code, so to the virtual machine. and then to assembly code. Okay, and this will be assembly code for my particular computer that I'm using now. And the second one will go from Python to JavaScript to machine code and eventually assembly. Okay, so this translation here will be standard, but everything that happens from then on will be dependent on which machine this is run on. And here, everything will depend on which machine it's run on. Okay, so now for the two examples, and in particular, the first one, a little program, helloworld.py. So here is the first example, the program helloworld.py. So on the left, you see that I defined some function hello of n, and you don't know yet the details of how to construct a function, but that's not very important. And basically what hello of n does is that it prints hello world n times. And then as part of this program, I do hello of 10, and then I print some new lines 3 times. So that's the program, and it's text that a human can read and try to understand, and it's text that a human could write. And now on the right, I'm in the same folder where this file is stored, and I do Python helloworld.py, and I execute it, and you see that this program performs as intended. It will print 10 times hello world and 3 new lines. The second example, as I said earlier, is certainly not a standard way to use Python, but it's meant to illustrate a possibility, basically. So if you go to this link, then you'll be reaching a website that has been developed for students to learn Python online. And this is called Code Sculpture. So you can write code on the left, and you can execute it and see the output on the right or in a window that it might open. And in order to execute it, you just press this play button. So let's see what happens here. So if there is some code that's already written, and if I press play, then I see that I'm basically interacting with a game. Okay, a mildly annoying one, but still. Okay, so what just happened? Well, I didn't have to install anything on my computer, actually, right? I'm just using my browser and reaching this site and then pressing play. So here, the code that's on the left, the Python code here, was translated into JavaScript, and my browser already knows how to run JavaScript programs. It's used all over the web, so I've already installed JavaScript before if you want. And this translated code, this translated JavaScript code, is now run by my computer. And it's by the computer, not by the central server that I'm reaching. It's really by my own computer. And that's the main advantage. It helps distribute computations to other machines or to users that access websites and things like this. And that's what Code Sculpture does. It really translates most of Python, not quite everything, but most of Python to JavaScript. So it will allow thousands, tens of thousands, hundreds of thousands of students to program in Python in parallel and actually run the programs locally on their machine. So Code Sculpture is really a good option for you to try if you don't have access to a computer with Python. It's a good option for most of the course to develop your own programs and test them. But be careful, it doesn't implement full Python, and in particular, it doesn't implement many of the libraries that we'll use later in the course. So we've seen our two examples, one directly running Python or py files, and one going through JavaScript. So now we would like to look at who is performing actually those translations. And as I said earlier, I already gave it away, it's compilers and interpreters. So you have to be careful when you talk about compilers and interpreters, because very often there is some confusion or at least some mixing of names that can lead to confusion. So if you remember with my Hello World program, I typed Python helloworld.py. So when I typed Python, I called a command that was really a compiler or an interpreter, some program to run on this helloworld.py file. So there is the confusion. I'm using the same word, Python, to refer to both the programming language, but also the compiler or interpreter, the program that will run on files written in this programming language. And sometimes the confusion even spreads more widely, because you might say a Python file for a file that's written in the Python language. So this confusion can be, confusing, so it can lead to problems. But the same word is basically reused for many purposes. Okay, so now it's time to learn about really compilers and interpreters. So they are programs, and what do they do? Well, a pure compiler for a language L will translate the source code in the language L to assembly code once and for all. So we had this picture, always the same picture of a programming language, and then assembly code on the right. And, well, the point was there existed an automatic translation like this. Now, basically, the main thing that could happen is you could translate everything at once, or you could translate line by line. And that's the main difference between a compiler and an interpreter. A compiler will take everything here, the whole source code, and will translate it once and for all into assembly code. So that's the compiler here. It's on the top, a compiler here. Now, an interpreter will do slightly different. It will work step by step. So it will take one line of the programming language, translate it into assembly code, and then take the next line, translate it to assembly code, and each time it's doing the translation, it's executing that line right after. Okay, so all this together, that's the interpreter. So the interpreter, if you want, works line by line in a program. Okay, and it goes back and forth between programming language and assembly code. So often the interpreters are slower than the compilers, and they have to redo a lot of the work, because if you rerun the same program with the interpreter, you have to reinterpret every line. You have to redo this translation again and again and again. While with a compiler, well, you just do the translation once, and then you run this translated version again and again and again. You don't have to do the translation again. So definitely compilers have advantages over interpreters in terms of speed. But interpreters have other advantages. The interaction is much more rich, much more interactive with the programming language and eventually the human, if you go back. It allows for more dynamic programs, and it gives more control, if you want. It's a more rich interaction in general. Okay, so where does Python stand in this? Is it a compiler? Is it an interpreter? Well, let's look back at our examples, and let's look back at what happens. Actually, let's look back at the first example only, because I don't really have control over what's happening here, and I don't want to start explaining what JavaScript is. The advantage with the first example is that I can explain everything that happens within the Python world if you want. So what actually happens when you run a Python file? Well, on the right, I have my folder on my computer where I have two files, helloworld.py and modulecompiledis.py. So you should ignore the second one for the moment, so just concentrate on helloworld.py, which is opened here. And this file we've seen before, it's a definition of a function, so you don't quite know what a function is yet, ignore that. But hello of n basically prints hello world n times. And then we call hello 10, so we'll print 10 times hello world, and we print some additional spaces. Okay, so if I run hello world.py, I get hello world 10 times and some spaces, as expected. And if I look at the content in the file folder, this hasn't changed. I still have those two files. But this is actually hiding away a few things that Python was doing when executing this hello world.py file. And that's why I have also the module compiled this file that will help explain what's going on. So this file is now here, and it's in two parts. So it's trying to illustrate two different things. So let's focus on the first part. Let's execute Python and then hello world, module compile this.py. So I'm actually executing this on the left. And what will happen? Well, what will happen? Let's see. Let's execute it. And what happens is that there is a compilation step here that is asked from Python. So I'm importing some new modules, so ignore that aspect of the program. I'm just basically compiling hello-world.py. So I'm making explicit what the Python command does actually when it tries to read in hello-world.py. And the result here, it's not what you see over there. That's the result of the second part of the program, the part here. The result is really in the files. So if you look, I have now another file in my computer called hello-world.pyc. And this file is the machine code that Python has understood it should produce from my hello-world.py file. So that machine code is meant for a machine to read, right? It's going to be complicated to look at it. So I don't quite want to look at it yet. What I want to do is I want to use Python to tell me in some more human-readable version what is inside of that file. And that's what's happening here in the second part of the module compile this.py file. So this here is a module called disassembler. It's the disassembler module. And what it will do is it will first go in the hello-world.py file. It's this command from hello-world.py, import hello. So what I'm doing is I'm importing hello of n, I guess. I'm importing this function. I'm also executing this part, and that's why when I run above here Python module compile this.py, you saw that this part was also executed. So this is the result of executing hello-world.py, and this happens here because I've imported hello world here. Okay, so that those 13 lines or so are the result of line 6 in this module. But then what I'm doing here is I'm disassembling the function hello. So what Python does then is that it looks at the machine code it would produce for the hello function and will try to translate back each instruction that it sees in machine code into a human readable format. And that's the output you see over there, the second part of the output. And what do you see here? Well, you see that you have some call to a function, some definition of a constant, the hello world constant, some printing instruction, and some jumps and for, and this has to do with the looping that occurs here. Okay, and you can see the range as well somewhere here being defined, so the range n. And finally some return value, which in this case is none. So that's why you see a load of a constant, return none. Okay, so this is the human readable version of the machine code that is produced when you run a Python file. And remember, this actual machine code is stored in a PYC file. So I'll try to give you a brief look at what that file might actually contain, but that will be complicated. So instead, I'll just print the end of it, so with the command tail, and you see that here you have the machine version of that file. So you see, you recognize some parts, but it's definitely going to be complicated if you compare it to the machine readable version here. Okay, so this part here is only ever meant for a computer to look at, while this part here might be actually meant for someone really interested in Python, or someone actually programming the Python program itself to try to debug different things and to help with this programming. Okay, so basically my point here is that whenever you do Python hello-world.py, this whole thing is happening behind the scenes. A PYC file is produced, which is machine code, and then this machine code is actually interpreted. So it's in two steps. First, you compile to a PYC file, and this is done once, and then you interpret that PYC file. So if I redo Python hello-world.py, in this case, it is actually recompiling, because there is a shortcut that Python takes, or an extra step that Python takes, which is to clean up the hello-world.pyc file that it creates afterwards. So each time it's recompiling and it's interpreting from the machine code. But this is specific because we have a very simple Python program. But in larger Python programs, it will produce lots of PYC file. For every PY file, it will produce a PYC file. And it will keep it for as long as you don't change the PY file or any of its dependencies. If you do change it, then it will figure out what it needs to change to adapt, and it will recompile to a PYC file. And that's done once, the compilation step, and then the interpretation step is done again and again. So that was meant to illustrate a little bit of what's happening behind the scenes when you execute a Python program. So what about Python? Is Python an interpreted or a compiled language? Well, the answer is that it's neither of the two. You can also have mixed behaviors where you go through some compiling steps and some interpretation steps. And that's what Python does. You will compile your source code, your Python source, into machine code. So that's a compilation step. And then this will be interpreted again and again to go to assembly code. Okay, so Python does a bit of both. It compiles with an intermediate stage and then from there interprets. Still, for some reason, people refer to Python as an interpreted language most of the time. And in particular, they'll use the words Python interpreter to refer to the Python program that runs Python files.